Hi everybody, here's part 2. So in the first screencast, we went over the basic functions and we did translations and reflections. Today what we're going to do is stretchings and shrinkings. So that's what's up for this screencast. So what we're going to do now is talk about vertical stretching and shrinking. So just like I did in the previous screencast, I want you to go to your graphing window and I want you to graph these three functions: x squared, 5x squared, and 1 over 10 x squared. You can type them right here in your calculator. So x squared, 5x squared, and 1 over 10. Make sure that when you're doing this yourself, that you're typing it in there exactly the way I have. You have to have the same parentheses, same keys, so that you get the same pictures that I did. So if you look at the graphs, so we're going to talk about what happens here. So in these examples, look at them. Look at these graphs. So remember, the original graph, the parent function, if you will, is in blue. Now, what happened with the red function? When you multiplied by 5, what happened? Got skinny, right? And when you multiplied by 1/10, it got fat, if you will. So I like to say fractions make it fat. Fractions make it fat. So look at this. So the graph of y equals 5x squared is the graph of the parent function, which is y equals x squared, but it is vertically stretched. Now vertically, remember, is think about that y-axis. So you are stretching it vertically, so pulling up and down on it at the same time. And when you do that, that's making it skinny. Imagine you're holding a balloon and you have one hand on the top of the balloon and one hand on the bottom, and you are pulling up and pulling down. You are making that balloon skinny. It is vertically stretched by a factor of 5. Now, what about the fraction? Remember, fractions make it fat. So that 1/10 in front of x squared is going to vertically shrink it. So we're pushing down and pushing up at the same time. And that's making it spread out left to right. So it's shrinking it vertically by a factor of 1/10. Vertically shrunk. So here's a summary of the vertical stretching and shrinking. All right, now what about the horizontal stretching and shrinking? So in this one, I used absolute value for my examples. So type those in your calculator. And after you have those all typed in your calculator, press the graph button. And then you should see the graph of these three functions, and they are color-coded. So our parent function is in blue, and look at what happened to the absolute value of 8x, and look at what happened to the absolute value of 1/4 x. Remember what Mrs. Dunn said, fractions make it fat. The only thing is now we're talking about horizontal. So horizontal is like the x-axis. So imagine you're holding that balloon on the left and the right side. And if you're going to shrink it, you're pushing in on it, which makes it skinny, if you will. So this is going to be a horizontal shrink, what's in red, or you're pulling left and right, and that's going to be the same as a horizontal stretch. That's spelled out here for you. So the graph of y equals the absolute value of 8x is the graph of y equals the absolute value of x, which is the parent function, but it's horizontally shrunk. Understand that we're pressing left and right towards the middle, and so it's shrinking by a factor of 8. And the other function is stretching by a factor of 1/4. And that's summarized on the next screen. So For horizontal stretching and shrinking, it's all about the numbers being on the inside. If the number on the inside is a number bigger than 1, then it's going to shrink horizontally. And if it's a fraction, it's going to stretch horizontally. All right, that's it. Be sure to tune in to my next screencast where I go through some specific examples from your homework. All right, good luck.